Yo, what's up, crew? Welcome back to SAT Hijackers, the channel where we hijack the SAT one problem at a time. Today, we're diving into the geometry questions from Practice Test 4, Module 2. But this isn't just about getting them right, it's about getting them done fast. Let's be real, the SAT doesn't care how smart you are if you can't beat the clock. You've got under 90 seconds per question. And geometry, that's where most people slow down, second guess, and lose points they shouldn't. So here's the mission. I break down each question the way you should attack it on test day. Clear steps, smart shortcuts, and no wasted time. Let's go. So here we have a pretty simple transversal problem. In the figure, lines M and N are parallel. If x equals 6k plus 13 and y equals 8k minus 29, what is the value of z and x? So here we just have to use a simple concept of vertex angles. See, x is congruent to z, so I'm going to have 6k plus 42 is equal to 8k minus 29. Minus 29. So now we're going to do plus 29 on both sides. We're going to have 6k plus 13 plus 29. 29 on both sides. So 13 plus 29 is 42. So we're going to have 6k plus 42 is going to equal to 8k. And then we simplify even more. So we're going to have minus 8k, minus 6k on both sides again. Minus 6k. Which is going to leave us with 2k on the right side. So 42 is going to equal to 2k. Is going to equal to 2k. Now we simplify once more, divide by 2 on both sides. You're going to have k is equal to 21. K is equal to 21. And now you guys are going to see b on the right side. You're going to get tricked, but that's not correct. So now we're going to do x is equal to 6 times 21, because we're going to input k into the original equation for x. 6 times 21 plus 13 plus 13 plus 13. Then once we simplify all that together, we have x is equal 139. And now this is where your knowledge of lines comes in. Because a straight line always adds up to 180 degrees, the x and the angle on our left is going to add up to 180 degrees. So I have to subtract 139 from 180. So we're going to get our angle, missing angle on the left, which is going to be 41. And I'm going to draw this missing angle over here. I'm going to write it as b, because those two angles have to add up to 180. So which is why we subtract the minus 139. And there's another rule. Those two corresponding angles are congruent to each other. So b is equal to z. Since b is equal to 41, we can say that z is equal to 41 degrees as well, which makes our answer C. So here we have a pretty tricky triangle problem dealing with SOHCAHTOA. So it says in triangle JKL, cosine k equals 24 over 51. And angle J is a right angle. What is the value of cosine L? So here I'm going to draw a right triangle to help you guys visualize this problem. Just going to have a right triangle. And now I'm going to draw my right angle for J. Right angle is J. Right angle is J. And then now I'm going to follow the format. So we're going to have JKL as my points. JKL as my points. So now I'm going to draw SOHCAHTOA to help you guys visualize what this cosine represents. So we're going to have SOHCAHTOA. SOHCAHTOA. So we have cosine k. It's going to write it as cosine is equal to adjacent over hypotenuse as shown in our equation up top, our abbreviation. Adjacent over hypotenuse. Over hypotenuse. And now that is the same as having 24 over 51 24 over 51. And now that's going to represent our cosine k. So our cosine k, our 24 over 51, is the same as its adjacent side over its hypotenuse. So now we can draw on our triangle and say that our adjacent leg is 24 and our hypotenuse is 51. And that's what that cosine k is equal to 24 over 51 represents on a triangle. So now we're going to simplify this ratio, as this cosine is also considered a ratio, if you guys didn't know that. We're going to simplify it, divide by 3. So we're going to have 8 over 17 as our greatest common factor. 3 is our greatest common factor in this ratio. So we're going to divide by 3, 8 over 17. And now I'm going to draw this ratio as a variable. So we're going to have 8n over 17n. So the ratio of leg to hypotenuse is 8n to 17n. So you're going to have 8 to 17. I'm going to write it as a ratio, 8 to 17. So now we can write this as a Pythagorean theorem to find our missing side, LJ. So we're going to have a squared plus b squared is equal to c squared. So now we know our leg and hypotenuse. So now we can put x squared plus 8n squared, as we're writing out our ratio for our leg, is equal to 17n squared. 17n squared. And now we can write x. This is in parentheses, by the way, so we're multiplying the whole numbers and the variables. So we're going to have x squared plus 64n squared, as we're distributing to everything inside the parentheses, the 8 and the n, is equal to 289 n squared. 289n squared. So now this two-step equation. We're going to subtract 64n squared from both sides. So now we're going to have x squared, subtract 64n from both sides, n squared. So now we're going to have x squared is equal to 225 and 225n squared. I have 225n squared. So now we're going to square root both sides. So now we're going to have x is equal to so now we're going to write our side LJ or x. LJ or x, same as x, is equal to 15 once we simplify that. 15n. So now we're going to have cosine. Now we're looking for a value of cosine L. Now that we know what LJ is, we can now find for cosine L. So that's same as adjacent over hypotenuse. Our adjacent side is now 15n. We can have 15n over our hypotenuse, which is 51, over is 17n, pardon me, 17n. Now we're going to simplify. So cosine L is the same as saying 15 over 17. So that's the value of cosine L.